going to discuss ellipses today. So ellipses are not a circular shape, it's like an oval shape that we have. Okay? So our very specific way that we define an ellipse mathematically is that it's the set of all points, okay, in a plane whose sum of whose distances from two fixed points, f1 and f2, is constant. Okay, so we have this thing called a focus and this thing called a focus. These are our two fixed points. Okay, so then the sum of the distances, okay, so we're going to use this picture now. So if we take the two foci, which is plural for focus, so the two foci, this sum is the same as this sum, which is the same as this sum. Okay? So all of these are the same distances. Okay? So what it looks like when you create it is like this. So we're going to watch this little video. So the toothpicks are the foci. So then they're creating the two side lengths. So that string, that distance of the string isn't changing at all. And that creates our ellipse. Okay. So we've got a few things that you can, vocabulary words that we need. So we have a vertex. The line that's connecting the foci intersects the ellipse at 2 points called the vertices. So if we were to take, here are the foci, then these two would be a vertex and a vertex. Okay. We also have, you can have ellipses oriented two ways. One where it's short and fat, and one where it's skinny and tall, right? So here, the foci, these would be your vertex. Here are the foci, and these would be your vertex. Okay. We use these other 2 points. You can call them co-vertex if you would like, or co-vertices. Okay. Now we also have something called the major axis and the minor axis. So your major axis is the axis, the longer of the two sides of the ellipse. Not sides, but the two distances. So your length or your height. So your major axis can go either direction. So your major axis, it's longer or it's higher. Your minor axis is the other one. Okay. So this is your minor axis, and this is your minor axis. Okay. And like I said, your ellipses can be oriented one of two ways, where it's short and fat or where it's skinny and tall. Okay. Now we have a standard form of our equation for an ellipse. So here we have this, where this part looks like the formula for a circle. We've got this part that is being divided by something, and then instead of equaling r squared, it equals 1. Okay. Now notice these two are very similar. The only difference between these two is which is the major axis and which is the minor axis. So we always define the A to be the major axis. Color that. Okay. And we define the B to be with the minor axis. Okay. So this one, this goes with this kind of shape because the major axis is with the y's. Notice the A goes with the major axis, which is under the y amount. And then here, this one goes with this shape where it's short and fat because the major axis goes with the x. So it's longer in the x distance than it is in the y distance. Here, the A value is bigger, so it's longer in the y distance than it is in the x distance. Okay. The only reason that we do this part right here, that A squared is bigger than B squared, is to define which one is the major axis and which is the minor axis. Okay? So I like to just remember it as whichever one it's underneath is which it goes with. So this, it goes with the x's, this goes with the y's. We also have this formula here that we need, where we have a squared minus b squared equals c squared. So I remember it's like the Pythagorean theorem, except for you're subtracting. Okay. So if we look here at this picture, this kind of lets us know what our a, b, and c is. So if it's the short and fat one, the a is our distance from the center all the way to the vertex, from the center all the way to the vertex. The b value, which goes with the minor axis, goes from the center to the co-vertex, or up and down by that amount. Okay. Now this c value that we found right here is representing how far to the focus. So the c value gets us to the focus, which we use to create our ellipse. The a value gets us from the center to the vertex. The b value gets us from the center to the co-vertex. Same kind of thing here, except for it's oriented differently. Notice that the a is under the y because our a is always bigger than our a squared is always bigger than our b squared. So from the center, we go up by a and down by a, and that gives us our vertices. And then we use the b value, and we go from the center left and right by the b, and that gives us our co-vertices. The c value that we find using a squared minus b squared gets us to the focus, so we can find where the focus is located. Okay? So let's take a look at graphing and stating what the foci are. So when we're looking, oh, I neglected this part. When we're looking at our picture here, we find our center the same way we find the center of a circle. So it's the opposite of inside here, the opposite of inside here. So our center is located at HK. Okay. So it's similar to our circles in that way. Okay. So here we have no A or sorry, not A or B. We have no H or K value. This is really the same thing as x plus 0 quantity squared over 4 and y plus 0 quantity squared over 36, right? So the way that I decide the center is by doing the opposite of inside the parentheses, opposite of inside the parentheses. So our center is located at 0, 0. Okay? So here's our center. Okay? Now, the way we determine which thing is A or B is which one is bigger. Okay? So here we're going to take this is our A because this is our A squared rather because it's bigger. Okay. So this also means that it's going to be oriented so that it's taller than it is wider. So this is the tall and skinny one because the thing under the y is bigger than the thing under the x. Okay. So if we set each one of these 36 equal to a squared, then that means that a is 6. If we set b squared equal to 4, then we know that b is 2. We're just taking the square root of each one. So that means that I can draw my vertices and my co-vertices. So from our center, because the 36 is under the y, we're going to go up and down by 6 from our center. So 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. And then because the 4 is underneath the x, that means we're going to go left and right by 2 because that's the square root of 4. So 1, 2, 1, 2. Notice that the major axis is along the y's, which should make sense because that's bigger than the minor axis that's under the 4's, right? Or under the x's. So I get this elliptical shape. Okay. Now, we also want to be able to state the foci. In order to find the foci, we need to be able to find our c value. Because remember, if we look back at our picture, our c value is from the center, adding the c value gets us to the foci. So what I want to do is I want to use this to figure out where my foci is located. So we're going to use a squared minus b squared equals c squared. So we're going to do 36 minus 4 equals our c squared. So that gives us 36 minus 4 is 32, gives us our c squared. We're going to take the square root. So we're going to break this down. So it's 4 and 8 and then 4 and 2. So we have a pair of 4's and a loner 2. So we get 4 root 2 equals c. So your foci is always along the major axis. So here's our major axis. So we're going to go from the center. And so since we're going along the major axis, that means I would go up and down by our C value. So we're going to go up and down by 4 root 2. Now, if you need a decimal approximation of 4 root 2, so you can see where you're at, or how much you should be going up by, that's 5.6. So that means I would go up 1, 2, 3, 4, 5.6, so almost all the way, almost all the way. Okay. Now, if we want those numbers, those points precisely, we take the x value of the center, because that's along our major axis, and then we go from the y value of the center and then up by the foci. Well, the y value of our center is 0, and then we're going to add the foci, which is 4 root 2. And then we're going to take the center y value and then subtract, not add, we just added, subtract the 4 root 2. So our foci are located at 0, 4 root 2, and then 0, negative 4 root 2. So I'm just going to keep it as plus or minus 4 root 2. 0 plus or minus 4 root 2. Okay. Let's take a look at, I just want to make sure. I guess we're going to do this one. Okay, so here we do the same kind of thing. So our center here, notice there's nothing inside our parentheses, so our center is located at 0, 0. Okay. Underneath the x is 49, so that means that we're going left and right by 7. And underneath the y is the 20, so that means that we're going up and down by the square root of 20. Well, the square root of 20 is 4 and 5. 4 breaks down to 2 and 2, so this is really 2 root 5. So if we do 2 root 5, 2 root 5 is 4.47. Okay. Or 4.5 essentially. You're not going to be that precise of 4.47 versus 4.5 on your graph. Okay. So I know that the x is the major axis because 49 is bigger than 20. So I'm expecting that this will be short and fat or longer left and right than it is up and down. So I'm going to go left and right by 7 from our center. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to go up and down by 4.47. 1, 2, 3, 4, and then almost a half. 1, 2, 3, 4, almost a half. Right, so we get this elliptical shape right here. Okay. Now, again, the foci is located along the major axis. So our major axis is this one. So to find the c value, we're going to do c squared as a squared minus b squared, with a squared always being the bigger thing. So we're going to do 49 minus 20. Remember, the things underneath are already squared. Right? So if we do 49 minus 20, that gives us c squared, is 29. So we're going to take the square root of 29. So c is plus or minus root 29. Okay. So we're going to be adding root 29 and subtracting root 29. Well, we can get a decimal approximation of root 29. So the square root of 29 is 5.38. Or you can think the square root of 25 is 5, the square root of 36 is 6. So it's somewhere between 5 and 6. That's another way you could look at it. So 5.3. So from our center, we're going to go along the major axis left and right by the c value. So 5.3. So 1, 2, 3, 4, 5.3. And then 1, 2, 3, 4, 5.3 right there. Okay. So our foci, the actual points, are, we're going left and right from the center. So from 0, we're going left by root 29. So left by root 29, and then up and down by nothing because we keep the y value. And then we're going right by root 29, and then up and down by nothing because we're on the major axis, which the y value is at 0. Okay. So that gives us our graph. Okay. Now, what if it's not... oh god, where's my brain? Centered at 0, 0. There we go. So here our center is the opposite of inside here, so positive 2. And then the opposite of inside here, so opposite of negative 4 is positive 4. So our center is located at 2, 4. So right there. Okay. Well, that means our a squared is the bigger of the two underneath, so 16, and our b squared is 9. A squared is always defined to be bigger than b squared. Okay. So that means that underneath the y's, we have 16, so we're moving left and right by 4. Sorry, not left and right, up and down. My bad. Up and down by 4 because it's under the y's. Y's go up and down. And then under the x's is 9, so we're going to go left and right by 3. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So we get this kind of shape. So more circular because 3 and 4 are not that far apart. But still not an exact circle. Also, I didn't draw spectacularly. Okay, so if we're going to find our foci here, okay, notice you have to go along your major axis. So remember that your major axis is the one that's bigger. So this is our major axis. Okay. So we're going to go from our center, and then we're going to move up and down by our c value. So to find our c value, we're going to do c squared is a squared minus b squared. So 16 minus 9. So c squared, if we do 16 minus 9, that gives us 7. So that means that c is root 7. So that means I'm going to go from the center up by root 7 and down by root 7. So if we do the square root of 7 on the calculator, the square root of 7 gives us 2.6. So we're going to go up and down by 2.6. So 1, 2.6. Oops. 1, 2.6. So here, down 1, 2.6. So about there, right? So those are our foci. Okay, but now we want to find those values. So notice our x value is going to be the same on both our foci. So they're both going to be at 2. Okay. Then the y value, we started at this y value, which in this case is 4. So then we're going to take our 4 and we're going to go up by the c value. Well, our c value is root 7. So we're going to take 4 and we're going to add root 7. So this one is located at 2, 4 root 7. This one on the bottom, we're going to take our y value of the center and go down by the c value to get to this foci. So we're going to start at 4, but then I'm going to take away root 7. Whoops, I already have a parenthesis or comma. So these two right here are our foci. Okay. We're going to skip that next one and we're going to look at this one. Now, this one looks different. We're not dividing by anything. Notice if we go scroll back up to our standard form of our equation, notice it has to equal 1. So all of these before equal 1, equal 1, equal 1, equal 1, not equal 1. So I have to get this to be equal to 1 in order to use the information that we've done above. So what I'm going to do is I'm going to divide by 144 on both sides. When I divide by 144, that means I need to divide this part by 144 and this part by 144. Okay? Now, you can use your calculator to help you reduce this. So I'm just going to do 16 divided by 144 in the calculator. If you're using the Desmos calculator, you can hit the little circle button that looks like a fraction off to the left. So this will give you or to the right rather. So this will give you 1/9. So this reduces to 1/9. So that's really x minus 3 squared over 9. And this is an unsaid 1 right here. If you're using your TI calculator, I'll show you this one. So you're doing 9 over 144. So you would do 9 divided by 144 and math, and then enter on frac. So that gives you 1/16. So this reduces to 1/16. So then I would have plus y plus 4 squared over 16 equals 1. Okay? Because 144 divided by 144 is 1. Okay? So if you have something other than equal 1, you have to divide by the thing that you have, and then simplify over here, and then that will equal 1. So now this is in our standard form, so now I can tell where my center is, and I can tell my a and my b values. So here, the center is located at the opposite of here, so positive 3, and then the opposite of here, so negative 4. So 3, negative 4, 1, 2, 3, 4 is right there. Okay. I know my major axis is with the y's because 16 is bigger than 9. So I'm going to be going up and down more. So this will be my skinny and tall. Okay. So this one, we're going to go up and down by 4, and then left and right by 3. So 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 1, 2, 3. Okay. So our major axis is with our y's, so we're looking that our foci will be up and down. Okay. So if I want to find my c squared value, I should say that's the center. So c squared is a squared minus b squared. So 16 minus 9. So our c squared is 7 again. So that means that our c is root 7. Okay. So that means from our center, we're going to go up and down, because up and down, the 16 is a bigger number than 9. So we're using up and down from our center because the major axis is on the y's. So our center is at 3, -4. So I'm going to take -4 and I'm going to add root 7 to that. So -4 plus root 7. And then I'm going to keep 3. That's my x value. And then I'm going to go down by my root 7. So -4 minus root 7. Okay. And this is where our foci are located. Okay. Now, you would have to divide by 36 on this one. We're not going to do the whole thing on this one. Okay, so 9/36 would give you 1/4, and 4/36 would give you 1/9. So I just want to make sure you remember that this, the center, would be 0, 2. Because we're not going left or right at all. And then here we're going the opposite direction, which is 2. Okay. Now, we also have where you can have, there we go, I had this one. This in our general conic form. Okay. Notice this does not look like anything that we've had before. What you have to do is you have to complete the square in order to get it to the standard form. Okay? So the first thing you're going to do is you're going to group the x's and group the y's. Okay? And then put the number on the other side. So I'm going to group my x's here. So here are my x's. I'm going to group my y's. Here are my y's. And then I'm going to put the number on the other side. You can do that now or later. Either one will get you to the same spot. So 4x plus 8x plus 25y squared minus 150y, and then I'm moving the 129 to the other side, so it'll be -129. Okay, so I grouped my x's, those are x's. I grouped my x's, grouped my y's, and then moved the number to the other side. Okay, now we looked at completing the square with our circles when we were doing this, but we didn't have a number in front. So the first thing that you have to do is you have to factor out the number in front of the x squared or the y squared. This is very important that you don't forget this part. Okay? That number has to be factored out. So on this one, we have a 4x squared, so I have to take out the 4. So when I take out the 4, I get x squared plus 2x. I'm going to do plus blank minus blank. Okay, so remember you have to take the 4 out of the x value as well. So 8 divided by 4 gave us 2. And then we are going to cut the 2 in half and square it. Okay? We're going to do a similar kind of thing with the y's. So I have to take out the 25. And then I'm going to get, 25 y squared divided by 25 is y squared. And then if we do 150 divided by 25, that gives us -6y. And plus blank minus blank equals -129. Okay. So now we're going to cut this thing in half and then square it. So we're going to cut 2 in half and square it, which gives us 1 squared, which is 1. We're going to cut -6 in half and square it, which gives us -3 squared, which is 9. Okay. Now to figure out this thing, we really were doing 4 times by 1, so I really was adding 4. So then I have to subtract 4. And then on this one, I was really doing 25 times 9. So I was really doing, if we do 25 times 9, that gives us 225. So I was really adding 225 here, so I have to take away 225. Okay. So now we're going to finish completing the square. So this, you either need to factor or it goes to the thing before you squared it. So this will be x plus 1 quantity squared. Bad choice of color. Okay, and then we're going to have minus 4 plus 25 times y minus 3 quantity squared. So it's this number here. And then we still have minus 225 equals negative 129. Okay. Now notice we've got these are like terms, so I can add those together. I'm not doing the numbers in front because notice those are being multiplied. This is being subtracted, this is being subtracted, this is being multiplied by this thing. So we're only taking these two numbers. So I'm going to get 4 times x plus 1 squared plus 25 times y minus 3 squared. And then if we do negative 225 minus 4, that gives us negative 229 equals negative 129. Okay. So I'm going to move this thing to the other side. So I'm going to add 229. So if we do negative 129 plus 229, that gives us 100. So we now have 4 times x plus 1 squared plus 25 times y minus 3 squared equals 100. Okay. Well, again, we're trying to get it so that it's equal to 1. So now it looks like this part that we had here. So now we're trying to get it so that it looks like this, where it's equal to 1. So in order to get this so that it's equal to 1, we're going to divide each thing by 100. So if we divide each thing by 100, if you do 4 divided by 100, that gives you 1/25. So this will be x plus 1 squared over 25 plus, and then if you do 25 100ths and you reduce that, that gives you 1/4. So this will be y minus 3 squared over 4. And then 100 divided by 100 is 1. So now we've changed it from this general convex form to the standard form where we can tell where our center is located. So now our center is located at opposite of inside the parentheses. So negative 1, opposite of inside the parentheses, 3. Okay. So I'm going to graph mine up here. I'm just going to create a graph. So we're negative 1, 3. Okay. On the x values, these are bigger, so this is our major axis. So we're going to go left and right by 5, and then we're going to go up and down by 2. Because remember, you take the square root of each of those. So left and right by 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. And then we're going to go up and down by 2. So we get this picture here. Oh, I missed. Okay. So we can find our foci. Again, this is on the major axis with the x's. So from our center, we're going to go left and right by our c value. So I have to find the c value. So our c value is a squared minus b squared. So 25 minus 4. So c squared is 21. So c is root 21. So from our center, we're going to go left by root 21 and right by root 21. Well, our x value of our center is negative 1. So we're going to go negative 1 minus root 21. And then our y value remains the same. So the y value of the center is 3, so 3. And then we're going to do negative 1 because we're starting from the center, the x value of negative 1. And we're going to add the c value, which is root 21. So plus root 21. And then we keep the y value because we're not going up or down at all. We're staying at the line with the center. So 3. So that's where our foci are located. So this is how you graph ellipses and find their vertices, their co-vertex, and their foci.